Dear student, today we are going to discuss about the concept of the half subtractor and full subtractor. So the before going to the explanation, so I want to show the detail about the half subtractor circuit. In half subtractor, it consists of two input A and B. So it consists of two output, difference and borrow. Okay, so this is the structure of the half subtractor. Here we are applying the 2 bits. So these 2 bits are the binary number. Okay, so difference and borrow is the difference between the two input. Borrow means when we subtract two number, if the subrahand is a minuend is less than the subrahand, then we borrow the neighboring element, neighboring digits. So that's why at the time the borrow will be activated. Okay, here this is the explanation about the half subtractor. Okay, here there are two input A and B and two output, difference and borrow. Okay, when the difference means the difference between the two input. Borrow means we get the borrow, we buy the borrow from the nearest neighboring digits. So at the time borrow will be activated. Okay, so here in a half subtractor, when we use the difference, so the XOR gate is exactly matched with the difference. But in the case of borrow, the AND gate consists of two input A and B, but the AND gate one input is complemented, so then we get the borrow. Okay, so this is the there are two gates are combined to form a half subtractor. One is a XOR gate. The XOR gate is fitted into the difference. The borrow is fitted into the NOT gate. Okay, then here already I show you. Okay, it produce difference between the two binary number, and already everything I told you. Here A and B, A is called as a minuend and B is a subrahand bit. Okay, then here this is the diagram. Okay, here now I am going to tell about the logic behind the half subtractor. First, there are two input A and B. 0 0 means there is no difference, that's why the difference is 0. 1 1 means also there is no difference. Here also the difference is 0. If it is one bit is 0, the another one bit is 1. Same as here 1 0 means there is a difference, so that's why it's applicable into 1 1. So this gate is called as a XOR gate. It exactly match the logic of the XOR gate, so that's why we use the difference as a XOR gate. In a borrow, we take the AND gate. The AND gate one input is a complemented, then we get the result as a 0 1 as a input complemented, then we get the result as a borrow. When we use the 0 1, we get the result as 1. Okay, here this is the half subtractor gate. There are two gates. One is a XOR gate and another one is a AND gate. The AND gate is a complemented, that means we use the NOT gate, then we get the result as a borrow. Okay, can you able to understand? Here the difference is a AND gate formula is A dash A bar B plus A B bar. Borrow means A bar B. Okay, so here next we are moving into the second gate, second logic circuit, full subtractor. So the full subtractor, here I show you the full subtractor. Here there are three input A, B and B in. B in means when we subtract these two element, finally we get one result that will be subtracted into this bit, finally we get the result. Here D is the difference. What are the difference between three element? Then B out means borrow output. Okay, so here there are three input and two output. Okay, so this is the concept. Then mm, here x y, so they said everything is same, like that previously I tell. Here a full subtractor is also a combinational logic circuit. It consists of a three input and two output. One is a difference, the another one is a borrow. Okay, then here we compare the minuend and subrahand corresponding position. Here now I am going to tell the truth table. Here there are three input. Okay, first this three input is 0. There is no difference, that means difference is 0, that's why the difference is 0. Here we are not borrowing any element. Now I show you. Suppose uh, this is the logic behind the subtraction. 1 minus 1, there is no difference, so that's why 1 minus 1 0. 1 minus 0, we get the result as 1. 0 minus 0, we get the result as 0. But here we are not subtract from this value. The minuend is 0, but subrahand is 1. So that's why we borrow from the neighboring element. Suppose it's not the value is not exist, that's why we move into the another element. So this is a this is a logic behind the subtraction. So here there are 3 0 means there is no difference and borrow. We are not borrowing any value. Same as here. 1 minus 1 0, 0 minus 1 1. So 0 minus 1 means the difference is 1, borrow is 1. Okay, here 0 0 1 means same as here. The difference is 1, the borrow. 0 minus 1 means we get the 0 minus 1, borrow is a 1. Okay, here 0 minus 1, then again 1 minus 0. Output is a difference is 1 and borrow is 1. So here 1 0 0 means here we are not borrowing anything, but the difference is 1. Okay, so 1 1 means there is no borrowing the value. So likewise we calculate the value. Okay, so this is the concept behind the full subtractor. This is the logic circuit of the this is a very complex bit. Here there are two bit A and B. So this is a one subtractor. Sorry, this is a one half subtractor exists, then the output will be added into difference, then bin result is also added into, then we combine the difference. This is another one complex circuit. This is the full subtractor circuit. Okay student, now I explain the full subtractor concept. If you have any doubt, please kindly post the doubt into my comment section. Thank you student.